or is it a competition? What?
It's not a strict competition because, as you know, we are seller for laser kits. So we are the subsidiary of our mother company, ETO. Our mother company is integrator, manufacturing commercial fiber laser cutters. And we, SkyFire, sell laser kits, laser parts, and do all the laser service around the lasers, such as upgrade power, repairing, fiber laser source repairing, and
Do y'all
how to
hear
say
that
we,
echo?
yeah, all around that. And as for this contest, this is our first DIY contest. So for those who have already bought our laser kits, they DIY their machine, and after they finish it, they can shoot a video explaining how they did it, and we can adjudge and allocate all of them as a participant and select top 3 and give some cash vouchers as awards.
I have a huge echo when y'all are talking, so I don't know if it's on my end or.
Your echo? Okay, let me
Actually, it's
try to
better now.
fix it. Extremely severe echo?
Yeah, it just repeats every word you say.
Okay.
I don't know if it's on your end or my end.
My side is perfect. Let me try to fix it.
Yeah, when I started it, it's fine.
I think at your side, you can try to wear a earphone and you can re-enter this room and select I am wearing a headphone or something. Okay.
Can you hear me now?
Yes. Even better. What about the echoes?
That's really bad.
Still? Oh.
Let me leave and come back. Is that okay?
My side is always good.
Yeah, let me leave.
Yes, waiting for you. Right. 那么你在那个你在准备是吧 Okay, Craig is coming. Hi, Craig. Hi, Craig. See you
Hey,
again.
hi, nice to see you.
See you again. Kyle just ended in, but he was experiencing severe echoes, so now he's trying to fix that and re-entry. Then we can start.
Let me, got multiple tabs open. Let me close some of these other ones. It's complaining over here.
So how is the sound at your side?
Your sound is great. Yeah, you sound
Is there
good.
any echoes?
No, I don't hear any echoes.
Okay. Kyle.
Yep. Do you hear me?
Yeah, perfect.
Yeah.
Any echoes?
Not anymore. I think I had two windows open and I didn't know it. So
Okay.
it was on my end.
Okay. I think we can start it. Actually, it has already started. So
Yeah, I have.
let me introduce myself and the lady beside me. I am Xiaodong, the marketing manager of SkyFire Laser, and this is Emily, the sales manager of SkyFire Laser. And this is our podcast, Laser Inside China. And today we're going to discuss about a hot project turning into a handheld fiber laser welder into a CNC laser cutter. I am joined by 2 innovators. The left in my window is K-Rigg. His YouTube account is K-Rigg. So has hardcore content packed with real THC experiment and usable data. And the right side in my window is Craig Hollabaugh, a true DIY spirit from our first DIY laser contest, who integrated also a fiber laser welder into a Crossfire Pro with a smart safety and control mouse. So you both attacked the same challenge from different angles, but by comparing where you overlap and where you differ, I hope we can truly demystify this hack for everyone watching. Okay, so I think I feel very honored to have both of you. Actually, this is my first remote online podcast with 2 foreigners. So I feel excited and also a bit of nervous. I want to first go with Craig. Craig, your pull out 50 in your video. I'm gonna share this video right now.
Okay. Good morning over there in China.
Okay, hold on. Okay, you guys can see it?
Mm-hmm.
Yes.
Okay. At 12:50. Hold on. Yeah. Here, I'm gonna pause it. And my question is that you called out the 125 psi for 3mm aluminum cutting. Does that mean you actually implemented gas pressure control?
No.
Okay.
No, the 125 psi is the maximum that we can get out of our shop air compressor.
Okay.
Okay, we'd like to go a little bit more, but we're just that's the highest we can get our compressor to go.
Okay. That's just my a little confusion. Oh, I'm gonna confirm
That's
with
fine.
you. And I've go through your video, all the optimization designs you have done for this project of your safety chain, the foot pedal, where the laser only fires where your foot is down, and the 3D printed clamp for quickly mounting the laser head onto the Z-axis, and your external fiber support bracket for keep the bands under control. Yes, to protect the fiber cables, and all that you did is impressive. And now I want you I would like you to explain to all the audience about your project, and you guys can discuss it. Yeah.
Okay. Yeah. So for those of you who haven't watched my video, I've had a Langmuir Systems Crossfire Pro CNC plasma table for about 5 years, and it's a very reliable machine. It really works well. We've been watching, like a lot of people, all these very attractive laser welders and laser cutting systems. Recently, all the shorts and things on TikTok and YouTube and Instagram. So we decided we had enough. We had the funds. We've got the funds together to go ahead and buy one. We wanted to try it out, and we got it, and it works really well. So we decided to see if we could actually just put the laser head, which you've seen here, is mounted on our plasma table, and have the control system in the plasma table basically pull the trigger on the gun.
Okay.
And
so
that's what we did. But there is a safety system built into these to keep the laser from being live and to control it when it's in a safe position. So we just implemented a foot switch. So you have to have your foot on the switch in order for the laser to turn on. And then if there's any problem, you take your foot off and it turns the laser off right away.
Craig, how about this? I stopped sharing your video. You share it, and you demonstrate your project with the...
Oh, okay.
Okay.
Hold on. Bring up that video. Guess I should have had that queued up, huh? Just a second here. The things that we did. So what you're seeing on the screen. Oops. Hold on.
Not yet.
So let me share it here. I think it's this one. Share my
screen.
Hold on just a second. I gotta do a little rigmarole over here. Okay, you can see this now?
Yeah.
Okay, so what you were some things you were talking about are the gun that my business partner got a 3D step file of we have our lasers equipped with a SUP 25T laser head. We got a step file for that, and he custom printed this holster that easily comes off with a thumb screw, and it enables us to easily pull this off, and we can switch from being a welder to a laser cutter in about 30 seconds. And then the things you were talking about to protect the fiber, there's a minimum bend radius on the fiber. See if I can figure out where that is. It's over here. So at the top of the bar where the plasma torch goes around, plasma torch is a little bit more forgiving. You want to protect the fiber from too tight of a bend. So we 3D printed this fixture at the top, and it's got a trough on it to hold the fiber bundle in at the top. And then as it goes down, we also fabricated some like little U clamps that kind of make a trough for the fiber to go down the backside of that. And this whole setup allows us to have enough slack to move all the way over the entire work area of the CNC plasma table, and it does not introduce any kind of tight curves on the fiber bundle. So we did that. We also did some other things. If you see over behind me,
magnetic 3D casted box for.
We have goggles. I bought five pairs of safety glasses from SkyFire, and I didn't want them like in a drawer or anything. I wanted them easily accessible, so we just made some little boxes that had magnets in it, and they stick right onto the wire feeder. And then that gray one on the end is where we have our consumables, because when you switch between a fiber laser, when you switch between a laser cutter and a laser welder, you got to switch the tip out. So we have all of our consumables in the the gray box, and also you'll see down on the machine itself, we have a 3D printed cover on top of the touchscreen.
I still did not understand what is that cover for.
In case you drop something, you don't want it to drop onto a touchscreen.
Okay. Yeah.
So we did that. So yeah, it's really functional. The whole thing, everything worked, and it was really simple for us to interface the two machines together. What we do not have is torch height control.
Kaya did it. So
and the guy,
I think
I was very interested in what Kyle did, and I'll let him talk about what he did. But I found it fascinating. As soon as you posted this video, I went and watched his video, and
yes, exactly.
It's nearly something. It's exactly what we need as well.
Yeah. So I go through both of videos. I think if you collaborate with each other, Craig, you did very optimization design for in the hardware, outer appearance. Kale did it software and the control system. If you collaborate with each other, the product would be better.
Oh, no doubt.
Okay.
No doubt.
Let's go with Kyle's video, Rig It. And how about that, Craig?
Yeah, let me stop sharing.
Okay. So, Kyle, you can share your screen.
Okay. Hold on.
Take your time.
Okay. Can y'all see that now?
Yeah. See it.
So let's, the laser I used wasn't one of y'all's lasers. I didn't really know about y'all until probably about a month ago.
It's okay.
But basically, this part right here is where I was able to. Oh, that's a commercial. So basically, this is just like how Greg did it. I integrated into the system to, for basically the plasma on and off.
Kyle.
Yeah.
Sorry, Kyle, you're breaking up.
I cannot hear sound.
Can you hear me?
Yeah, you broke up there, Kyle.
I'm sorry.
Yeah.
Now it's good, but
it might be when I'm trying to play the video, so I'll try to just kind of run through it. But let's get to the so originally I did basically the same thing as Craig did, which was just a simple mounting the head to the table and basically an on and off system. That was the first part of the project, and it worked great for small pieces, but needed something that I want to be able to cut a full sheet of material. So that's when I started to look into basically these torch height controls. And these are originally meant for oxyacetylene torches, where you have a flame torch where you can't, there's no torch height or there's no arc voltage like in a plasma cutter. So I was able to search the internet. It took me several days. But there's two companies I was able to find. This company is out of Vietnam, and there's another company that I haven't used theirs yet, but I bought this Capo 4 from the eBay basically, but I don't know where they're manufactured. Okay. But the neat thing about this is it basically takes the capacitance, which is the ring of this ring that the laser goes in, and that's how it senses the height of the material. And all it does then is give you basically relay inputs of either up or down signals that you can then, in your control software for your CNC plasma table, you can basically swap out what your plasma was giving from an arc voltage to basically use these systems. So it's very dependent on what your control system's like, but a very generic control system has your breakout board, which takes all the signals from your computer and then splits out to the motors, and then your outputs to your on and off or your laser or plasma, and then it's taking inputs from other usually boards like a THC that is, from a plasma perspective, is taking the arc voltage. Well, this is taking the capacitance from the plate, and it's just giving you the same signals. So from an integration standpoint, it's pretty straightforward. I had to do some software side of things where I didn't want the Z height to raise up every time after it cut, because I realized that with laser cutting, you don't have as much of a kerf width, so you don't have as many tip ups. So it really sped up cutting process, because with plasma, my table would always pick up about an inch, go to the next cut, go down, sense the material, and then go from there. Where this is always sense the material. Now there is some, there is some, a bit. There's caution to that because I have hit the laser head and with the tip up or things of that nature. But the neat thing I did is, and I actually have it right here. Can y'all see this on my screen? Or do I need to stop sharing?
There's ceramic or plastic?
So this is actually just plastic. I'm
plastic.
just
Okay.
a piece of aluminum and piece of plastic, and then this is the actual laser tip, and then this is just a little.
Yeah, you have to stop sharing.
Okay, sorry.
That's all right. Just stop sharing.
All right, y'all get it now. So basically, this is just a replacement to the cutting nozzle that you have on the
on the welder
system. So this is all screwed in, and this is just acting as a basically an insulator. And the reason that's important is because when you have this ring that goes around here, when it gets close to an edge of material, that ring might start not sensing the material and dip just below enough, because I have this almost touching the material when it's cutting. And so this system that I've kind of devised is with this little clip, I'm able to clip on that ring. And so that capacitance sensor is also sensing this tip. So what that allows me to do is to get really close to the edge. It's basically taking both systems to sense this and that to keep the torch high control. And I try to just use this by itself, but it wasn't enough. It wasn't enough area, because it's all capacitance always works off the area. That ring was enough, but this by itself wasn't enough. So, which makes it pretty neat, because I could just basically, my mount's just kind of like Greg's, where it just slips in and you got one little kind of screw that bolts it in. And this allows me to take the head out really quick. I take one bolt out for the wire feed and then put this on, put one bolt on to mount the table. And within 30 seconds, I'm cutting from where I had it set up for welding. So it's really nice to be able to switch back and forth. And for a small shop like me, that's the versatility of it is what really, just blows me away. Where I'm even thinking about getting rid of my TIG machine, because this laser welder, I've just been doing all sorts of cool stuff with it. And then with the laser cutting, the ability to get finer detail has allowed my setup and my fit ups just go to another level that, I just never thought was in my grasp until these systems came out.
Okay, Kyle, can I ask you a few questions?
Yeah.
Yeah. So first, congratulations for getting torch height control working. And how did you capture and feed the THC height signal into your controller? Is it a plasma style interface or something custom?
So a little background on my end. I used to own a CNC plasma table company that we manufactured tables and such. So I understood the intricacies of how all that system works. So a lot of these tables are manufactured with basic components that are similar. So I kind of knew what the control system needed from an input and output perspective. And then I was like, okay, how do I find, my way of kind of finding the solutions to everything is, I'm creative, but I'm lazy. Like I want to find the easiest solution out there. And so I was like, okay, what other system out there uses a torch height control, but isn't relying on the plasma? And so I'm like, well, I've seen these torch height controls on oxyacetylene and flame torches. So I then went down that road of like, okay, well, how do these integrate with a CNC table? And so that's how I kind of went down that road and realized, okay, maybe I can, that capacitance torch height control doesn't care what's in it, right? It's just using the ring. So I was like, well, why shouldn't it be able to use with a laser? So that's how I went down that road.
Okay. So another question: did you implement dynamic laser power control? Adjust the power.
No.
Okay.
Not yet. I thought about it because it with the software I have, it shouldn't be a big deal. But where I have that, just like Greg, where I have my system, my power source is right by my computer, right by my table. And, I just go over there and just adjust it on the actual machine. And, I know with I guess proper laser systems, you're able to adjust the wattage when you're coming into like a corner, or if you're doing holes and piercing and things of that nature. So I just kept that dumb, where like for 10 gauge, I just do about 1500 watts. And then on the software side, like on my pierces, because I don't want any of that reflection getting into the laser. I don't have any pierce delays. I just adjust my lead ins to as long as I possibly can, and I just let it go as soon as it turns it on. And so I try to modify the software where I'm not worried about the laser power as much. Now I will turn the power down for like thinner materials, thicker materials, things like that.
Yes.
Nature. But
Yes,
I kind of wanted to do this as simple as possible too.
Yeah, yes. So all the questions I asked just now, because we went through your videos with my teams, of course, Bruce, our technical director. So actually, the question is what he proposed, and I read it down because I am not a big tech guy. So I just Actually, I know he explained to me that these the aspects that we can upgrade the project what you have done, so you can make it better. Next question is that, so are you doing multi-stage piercing sequence or single steel shot?
I
Single
just
shot
hit
pierce.
one and go. Yeah, single. And I've been
Okay.
able to do
Okay.
2000. I have a 2000-watt machine. I don't know what Greg has.
Yeah, same. I have the
Yeah,
same.
the same.
But I mean, I've been able to do that. That's half-inch stainless steel that I've been
Okay.
able to cut. I mean, which is crazy because I don't think that's in the capability of that really machine.
Okay.
And you could see that, with the pierce, like I'm running that pierce as far as possibly can. So I know there's, in the proper machine, when you say double, I think that's what it means, is it's kind of going on a lower wattage to remove maybe the scale of the material first, and then it's blowing through. Is that what that's kind of referring to? But I've just found that as long as I can blow, turn the part on as quick as possible, by the time it gets to the actual cut process, it's already through. And I haven't had any real issues with the lenses, protective lenses, being affected by it. And the only issue I've had is because this is plastic and I hit something with the machine sometimes, because I'm using a 1.2 diameter nozzle. And the reason I'm doing that is because the same thing with Greg with the shop air. I'm about 110 psi. The smaller the nozzle, I found that I have less dross. I mean, I've been able to get it down. It's still a little bit, but not as much.
Okay.
The smaller nozzles I found has helped because it's just increased the velocity of the air. But the problem with that is if I hit something, I don't have any room for error, and it blows out this nozzle from the laser just cutting through. I mean, but it doesn't.
I think Emily can write it down. So maybe after this podcast, we can send some nozzles or consumables to Kyle and Craig.
So let me add a couple points. Let me add a couple points to what you're saying.
Sure.
So on our side, we control the pierce process with the post. We generate a post out of Fusion or out of SheetCam. And if we're going to cut really large, thick material, we do like what Kyle said. We intentionally get off the surface of the material, which increases the laser dot, and we're able to do cleaning at that point. And then we slowly traverse downwards to the cut level that we're going to be at. And my partner was cutting 5/16 cold rolled steel, and it came out we were running at 10 inches per minute, which is pretty slow, but we're able to get through that, and that worked pretty well. And so how when you're with your torch height control, what do you think your cut height is off the material with a nozzle, the nozzle tip to material surface?
It's a 1/16 of an inch, so it's really like,
oh, okay.
It's pretty.
Yeah, that's getting down there.
Yeah, so I'm right there on.
Oh wait, what is that? What is that in? What is that?
0.0625.
0.625. Oh yeah. No, we're able to we cut most of our stuff at 50 thou.
So you're a little
which is,
and mine's all just kind
we're
of
a little bit
by eye.
Right, but if our material has any bow in it, we're we end up dragging. And yeah, so that's where we want to get a torch height control as well.
Yeah, and the interesting thing with these torch height controls are, basically the height is just controlled by a potentiometer height, and
Right,
so
right.
you can't really dial in,
A number.
a number per se. It's literally like I let it go and basically touch the material, and then just turn it up a little bit because it starts to say a collision up, up, up,
Yeah.
and so
How does it? What does it work? How fast is the transient response on the torch height control?
I mean, it's
You
as
know,
fast as you have your settings on your motor control. Like I've actually turned mine down because it was pulsating a lot, and then
yeah,
I could tell that was affecting the cut quality because your focus was going. So
it goes in and out. Right?
I have that turned down, the motor reaction turned down quite a bit, so it smooths that out, so it doesn't react quickly to things.
What about when you're cutting parts that are close together and the capacitance changes because you've traversed over an area that you've cut out a part and there's no metal there left?
That's where this comes in. Like I can go an eighth of an inch and it'll follow it from a
Okay, so
empty part, like you got a
yep,
piece of scrap, and I could
yep.
butt something up almost kind of the way you do for plasma, where if you're going to manually nest something together, I haven't changed any of that sort of idea of
Okay,
like
so you're
putting something right there
okay.
in a hole.
So you can cut like a bunch of rectangles out as long as they're an eighth of an inch apart.
Yeah. And now if it's the same, if it's all on a clean sheet and those parts don't move, because I've noticed that with laser cutting, because the curve's so small, you don't have too many tip ups with thicker material. I know thinner doesn't matter, but you could use common lines then too. So
Yeah, I haven't done that.
yeah,
I don't have the confidence to do common lines.
I've done some stupid stuff. So, but it's
I've gotten
Good
really
compensation.
close. You know, yeah, I've gotten really close. I'll do, I don't know, a whisper. There'll be a whisper of a piece of metal left, but I haven't done any common lines.
yeah. Like here, let me see if I can. I think on this video, let me see if I have it.
Primarily because of the common line, the laser will blast down through the bottom of my table and hit my little protective surface on the bottom and bow it up even more than it already is.
Right.
I have a piece of sheet steel on the bottom of my plasma table that started out flat and it's no longer flat.
I have a piece of stainless steel behind mine, so I understand. But like here, right here, let me see here. Can I share my screen?
Of course. Sure.
So y'all see that right here? All right, let me play that just real quick. So you can see that like I'm on the edge of that plate. See how close I was to the other one? Let me see if I can zoom in. It's not letting me. So I mean, you can see right there. It's about even maybe less 1/16 of an inch.
Hmm. Okay.
So let me get off this.
I didn't know that there were THCs for arc torches. I mean, once I saw that, I was like, oh, let me see how this works. I mean, it was like within 5 seconds of you talking about what you bought. I was looking for those to figure out how they work.
Kaya?
How he might have closed the window that we were on. He'll probably join again.
Yeah.
Yeah. So I'll just say on my system works a little differently than Kyle's. Kyle's integrates in with you using Mach 3 or you're using Mach 3 controller.
Yes.
Yeah. So the Crossfire has its torch height control is looking for an analog voltage that is proportional to the torch voltage, and they just have a A to D running with a maximum of 3.3 volts. So they're expecting a voltage. They turn the torch on and they start to move and they average out about, I don't know, 200 or 300 voltage readings, and they lock in at that voltage level. And then when the torch goes up, the voltage goes down. The torch goes down, the voltage goes up, or the reverse. And they just follow along an analog voltage. So your approach has relay outputs for up and down. It won't interface directly in with the Crossfire design.
Well,
But I could take what you're doing and create a little analog circuit that reads those voltages in from the relay outputs that you're got, and then generate an analog voltage from that, which would equivalently work the same way. And then I wouldn't have to modify the torch height control on my plasma table.
yeah. I mean, have you actually opened up like a control box and seen what's inside that control box?
What they used?
Yeah.
Yeah, I could tell you a great detail what they use. They're using a Gerbil board for their motion control system, and then they're using an Arduino Mini as their torch height control system.
So how are they?
They have a US.
How are they?
They're both of those boards make a USB connection into the application that runs on the Windows machine. So when they're just streaming out the analog voltage out of the torch height control system as a USB serial connection. When they see that, when they set a value from the stream when it starts up, and then they basically send Z commands out every once in a while to correct for the height control. They do it in the control software on the PC. They don't do it in hardware.
What do they use as control software? Linux or?
No, they wrote a Java application, and it just runs full screen in Windows.
Okay. So you can't create like another profile with other settings or anything like that?
No. That's the unfortunate thing. But what I can do, because what do we use for the other lasers in the shop? Lightburn. We could use Lightburn on our plasma table, and I might be able to come up with some module that interfaces in and just move over to running Lightburn, because we have 3 other lasers in the shop that use Lightburn.
So,
and if we could migrate to using Lightburn on this, then anyone that's trained on any of the lasers can use any of the laser. You can use this as well.
So from that breakout board or the Gerbil, does it have, I guess, outputs to go to like the actual motor controllers?
Yeah.
So
Gerbil.
Go ahead.
Yeah, the Gerbil, they just run signals right over to 3 motor drivers.
Okay.
And then for X, Y, and Z. They have two Y motors, so they just parallel.
And are they just simple 5-volt wires, or?
Yeah. They're just straight step and direction control.
So with this, the torch height control I used, it had 2 options. You could either do the just up and down signals,
yeah,
or it actually had a splice where you can splice into that Z motor, and then that controls
that would
the Z motor.
Well, that'd be great.
Yeah. So that it has.
Do you have a way
to do that?
Do you have a way to enable the torch height control at some point after you started moving?
I can, because I use the up and down, but if you use the motors, I don't know how you would, because that's basically it's putting itself in between the motor control for the Z and things of that nature.
Right, because the way that this system works is it moves down in Z, and there's a limit switch on the Z platform. So when the actual mechanical mechanism on Z is loosely coupled to the lead screw, so they drive the whole thing down, and when it touches the metal, it disconnects that switch, and that's how they know where Z0 is. Okay. And then they pull up a little bit. So we'd have to still have that capability, and when it pulls up a little bit, then we want to basically turn on your torch height control that will send signals over to the Z motor driver and do all the control at that point.
So the way I would do it, do you have an option of not using the torch height control when you're cutting?
We can turn off our torch height control.
So what I would do is, if you put that torch height control in between the motor driver, it's still going to let the signals come from the computer. But like for mine, I mean, it's going to work the same way. Like I wrote my post where it doesn't write any Z heights, so it's
we can disable that in the post.
So then basically at that point, it's not going down to such sensitive material, because the capacitance is always working. So when you're jogging the machine over, it's always going to adjust up or down to what the machine is. So basically,
I understand.
Basically, what I would do is just write the post or run the machine like you're not using torch height control, and then have that torch height control basically control the motor
all the time.
Yeah, and the only downside to that would be your DRO for the Z probably wouldn't be accurate at that point, because it's sending signals directly to the motor controller.
Right. Yeah, we don't. That's not important to us. Right. That's fine. I don't care about that.
So that's an option for that.
Yeah, that would be good.
Okay. I love your conversation. And even though I cannot catch every single word of what you say, I think it will be very beneficial for our audience. And actually, I did another question for Kyle, and then I have a question for both of you. Is that okay? It's about the active cutting gas pressure control. I think it is also a point that can be upgraded for current project. Yes.
So really, I
So
think.
have you ever?
Go ahead.
Yeah, you go ahead.
So like, I guess the next step that I would take with this, if I wanted to like focus on probably better cut quality and such with the system I have, is I would try to find out or figure out how to basically get a proper cutting head and mount a proper cutting head to the table. And somebody's told me that these exist. I have yet to find them.
Yeah, exactly. It is already exist. I am not sure whether you and Craig have noticed that there is already some machines presented just like your project. They mount the laser welder on the bed, which is designed by themselves, and they say that it is an all-around machine. They can
Right.
weld when you want to weld. They can cut when you want to cut, and of course, and cleaning and welding. The questions I asked Kaya just now about the active gas control, about the multi-stage appearance, the dynamic laser power control, and THC height control issues. They already fixed it. I think only need one controller system. You can fix all these problems. Yes. So I think because I will not name their company name in this podcast, but we know that actually I think
Let me ask you this.
we can.
I was
Okay.
more going on, do y'all have or know that of any fiber, the QBH, is that the QBH? Am I referring to that, the QBX, fittings?
Yeah, I know KBH.
Is there a splitter that you can split the laser from the actual source to two different directions? Somebody's told me that they exist. Like it's a manual or electronic where it flips a mirror where you can go from the source and either go down one fiber lane or optic cord or the other fiber optic cord.
No, I'd be all over that. I'd buy that right now.
Because then if that exists,
Okay.
then I could basically mount a proper, what I mean by proper, like, an actual like fiber laser head onto the table.
Okay.
Because with like gas
Okay.
control and everything, that's where your dual nozzles and things of that nature would come in play. And like the handheld laser or handheld guns, just you only have a single, basically gas source. And so like when you're using oxygen or something, you want to be able to have an assist gas, low pressure oxygen, to help the cutting.
I think it needs a solenoid valve, according to Bruce said.
Well, you'd manifold up there. You'd manifold up all your
Right.
your source gases.
Right. But I'm talking about like the start to that. So I'm not having to like change over the fiber optic because that can get iffy in a dusty environment. But if I could have it where I have a fiber optic cable to the table and then a fiber optic cable to my hand laser,
Okay.
some
Yeah,
mechanism that uses the one laser supply that I could switch left and right to.
okay. I understand. That's a good. That
Is
was a
something that
good approach.
exists? Somebody told me that exists.
I'm not sure. I would ask Andy to source about it. That was a good approach.
I suspect that switch is probably going to be more. That switch will probably be more that expensive than just another fiber source.
Probably.
I don't know. Because this is what we were thinking along the same lines. Because we bought a BM110, a real fiber head, and we didn't know if we wanted to have a 100% dedicated laser cutter or we wanted to have a laser welder. And we really fell in love with the welding portion of it, but we were missing out on the cutting part. That's why we went down the road of just seeing if this would work. I mean, we figured out if this was going to work in a couple of hours because I actually had all the right connectors already. So I just looked at the manual and I cross-wired everything, and we were giggling at how easy it was for us to connect them together and what we were getting out for literally no no cost at all to us.
I understand. So for your routine work, you probably do welding more.
We do both,
Okay.
My projects involve everything along those lines.
Yeah. Okay. So one question for both of you. So if there
Oh,
is
let me go.
a
Let me say one
okay,
thing though. Let me say about
okay,
this
okay.
your gas question. The limitation on my SkyFire Blazer,
Mm-hmm.
the internal gas valve is a low pressure gas valve. It won't work above about 250 psi.
Mm-hmm.
It will not open if you have gas higher than that. Okay.
Okay.
Sup 23T head has a maximum uh, um, pressure going through it at 225 psi. So you can't really get up to where we really would like to go. We'd like to get up to 300, but we can't generate that in air. Now, we have a local fab shop here that has a 12,000 watt fiber laser, and they only run compressed air, but they can run it at 300 psi. They started using nitrogen, but then they just switched to compressed air, and they bought a high psi air compressor, and they get really beautiful cuts out of that. And so if we could run at that higher pressure, we would do that. But for what we do, for the amount of work that we do, we live with the dross and live with what we have, and it works fine for our workflow.
Okay. So you both are already technicians at this aspect. So you owning these some small devices or units, you can overcome the problems you have facing now.
Yeah, the quality of the cuts far outweighs the amount of rework of the cuts to get the dross off. What is minor compared to the quality and the accuracy that I'm able to get out of
Yes.
my cuts. And like Kyle said, our fit ups are excellent, which is what we need for the laser to laser welds. The combination of the two, we end up using more floppy disks basically to
Yeah,
clean up the.
I went and
Go ahead.
bought a big old belt sender to deal with,
Perfect. Even better.
big old, one
Okay.
of
So
those big, time savers just to feed the parts through, and that makes, then you don't worry about the dross after
okay.
that.
So you want a QHB splitter to split the fiber cables for dual use, and Craig, the suggestion is to improve the pressure of our blazer machine. Yeah, I think Emily has already written it down. And after this podcast, I will send you both of you the emails about the solutions related
Okay.
to your project. Yes. And
That'd be good.
mhm. and yeah, we actually are developing our consumable grade small laser cutting machine, and that machine is specially designed for you guys, like workshop makers. I can share you some. I think Craig has already seen that, right?
Talking about the mobile one? No, go ahead. Go ahead
No.
and share it. Go ahead and share it.
Okay, my screen is off. Jay, 你看一下我这里。
So I found a 1064 nanometer optical fiber splitter box from QHB
Okay.
on AliExpress, and it's $4,600.
Really?
Yeah, but that's just me looking for 30 seconds. It's specifically got the connectors on there to go to Rakis and IPC Max welding machines. So it might actually be an option.
Because the way I looked at it, from the reason I bought the welder and stuff, because I always thought of building a table for laser, right? Just a laser based table, buying all the components. But I saw that. That's really neat looking. I saw the TikToks and whatnot that y'all seen, and when I saw the person cut a shovel, I think it was a shovel that's in my mind with a laser handheld laser, and I was like, wait a minute, now, these can do all of that, and that's why I went down the laser welder way, because I was like, man, this can do it all, and
Yeah.
It's nice to have the laser source, the compressor, the chiller, all in one unit. And with there's a lot of people that don't have the space for all that stuff. And if they can have one unit and serve two purposes, I think that would be beneficial, because I think people really love multi-use tools. That's why Leatherman was so well.
There are already some machines can be multi-use
Right.
using. Yeah. You can. I will send you after this podcast. And the screen I'm sharing right now is the small laser cutting machine that can cut both metals and non-metals. For non-metals cutting, we use.
Yeah, I did see
Yeah.
this. I did watch
Yeah.
this. Yeah, this is great.
Yes. And also we specially designed a compressor for this machine. That is I'll show you.
So this is a step up from a desktop machine, right? This is how tall are these things? These are 5 feet tall or something.
For height, I think is under 2 meters.
Yeah, right. It's like the size. It's like the size of a milling machine.
The size we have two options. One is 1 + 1 feet squares and 2 + 2 feet squares. And now is 2 + 2.
And you're saying that for the metal you're using fiber, and then for the non-metals you're using CO
For normal, we call it the blue laser.
diode laser.
I think, yeah, diode laser. Yes, exactly. I'm gonna show you something.
And this handles all the vacuum system. You have air cleaning, air quality. You blow this through a cleaner, or do you have exit gassing? Or how do you keep the gases from accumulating inside of this?
I will not take too many times to demonstrate
that's
what
fine.
this machine is. I just so of course today's main topic is not about this. I just share a little bit, but what I can say is that we will make this machine modularly. What it mean? It means we designed the electrical parts modularly and the gas control parts modularly, and even the upper part and the lower part divided by the orange line can separate. Customers can buy it and can amount them up, assembling them up by themselves very quickly. Yes, plug and play, and we already tested it, and it has the very high acceleration and precision, and good cutting quality. And I will show you this one.
There's definitely a market for that. There's definitely a market for this product.
I think because this is air cooling machine, so we have this cutting air cooling one, and also we have laser marking machine air cooling one, and the laser welder machine air cooling one. We call it a air cooling family, and we will put all of them together in a workshop that we are building right now. We want to create visualized using application scenario for other people. Hold on, and I think this is
the laser marking. Is it a galvo motion system, or is it XY or core XY? Or I see.
This is the special designed air compressor for that machine. I adjusted.
Okay.
Yeah. So it has very high pressure, and yeah. Yep, that's it. So when this machine comes out, I will send you guys the first information, and we plan to shift this machine to the US as a demo machine, probably to Chicago, to LA. Yeah, you know, Travis is in Chicago, right? And we have another partner in LA. So we want people to try that machine.
Sure.
Okay. Okay, let's go back to the project, what you present. So if there's one thing that you want to deliver to the people who want to try to replicate your project, is there one thing that don't do that, the tips?
Yeah, I have a good tip. Don't try to cut rusty metal.
Okay.
Don't try cutting rusty metal, because almost 100% of laser energy does not penetrate the metal, and it bounces around a lot inside your shop.
Okay.
And these lasers are inherently dangerous. And if you see the sparks flying off, those sparks are driven by laser energy. They might be very intense, but they go everywhere.
Okay.
So if you're going to be cutting something and you just want to cut through some rusty stuff, don't even bother doing it. It's dangerous, and your cut quality will be horrible.
Okay. Good safety tips. What about Kyle's?
Yeah, I mean, on the safety, go ahead. I mean, on safety, I definitely try to be very conscious of wearing the glasses. Even when it's cutting, don't look at it, because it's not a properly designed machine where you have a cabinet around it. You don't have the proper laser shielding around it, so bystanders. I don't have anybody in my shop when I'm using this, so it's you are taking some risk, and you need to make sure that that laser light, you can't see it in your naked eye. And I notice when I film it, the camera will pick it up, and it's almost like a purple light, but you don't see it with your naked eye, and you have to be just really careful. Wear your safety glasses. And then the other tip I would be is just find somebody that has good customer support. Like when I bought my machine, they answered my questions and everything. They were good, but it's you want to make sure you buy something from somebody that's going to be able to answer your questions, because with this laser technology, it's new to us. I don't think there's a lot of people in the metal fabrication business over here in the States that I've dealt with this. And so find someone that's willing to answer questions and ask questions. Ask a lot of questions before you just assume. I want to assume anything, because these can be dangerous.
Yes, let's keep in touch, because I think you both are good person and a qualified person to do that job. Technical
Well,
questions about lasers.
yeah,
Yes.
that's the reason why I went with SkyFire. I could have bought one right off of Amazon. All right, roughly the same price, same kind of functionality, but I didn't know anything about these things. I mean, all I have is YouTube videos, and those, it's whether or not. But then, when Travis Mitchell came out with his series, and he was working on his second machine, he said, I've been using stuff from SkyFire," and he gave a vote of confidence to use you guys. And so I just contacted and started a conversation. I get very fast technical support from SkyFire.
Yeah. Thank you. And a shout out to Travis. Yeah. Great person.
He's doing interesting projects for you guys, and he was a good choice. He was a good choice for you for your ambassador.
Yeah, she always exploring the things that no one has ever done on the market. And I also want to go back to Kaya. Kaya, this is the first time so we get connected with each other, but I have followed your YouTube account for many times. I think for 3 or 4 months. You did very good hardcore content. But if I could give you a suggestion that you can devote more efforts on the videos, editings, and something like that. Yes. Yeah.
So
your content is great. Yeah.
You want more videos? Is that what you're saying?
No more videos. I would say maybe after this podcast, I can give you some suggestion skills to improve your YouTube account.
Yeah. Please do, because it literally is just something I kind of do on the side, and I do it for fun. Yeah.
Okay. That's all my questions, and I feel very honored to discussing with you, credible technician, and as one of the members of SkyFire, I would like to say our mission is not only sell the products and make profit. We want to connect it to the peoples in the circles, and we create together the community. So that's at least my how to say. I don't know. I cannot come out with English right now.
I understand.
So yeah. Okay.
No, it's fine. You're making a concentrated effort in supporting the DIY community, and I believe that you're probably the only company that I've seen actually doing that.
Yeah. Thank you.
The fact you have this podcast, you're running these competitions, your active support. You have a U.S. ambassador with Travis, and also Tamar. And so you're working your way there.
I think you.
That's us too as well.
Yes.
Sure. No, I like posting the videos. I don't get, of course, I don't get to the shop enough or as much as I want to, but I'll continue to post things as I make various
Yeah.
projects.
Yeah, and I think Emily will contact you after this podcast to give you
Okay.
some, like I just said, the consumables and the and some how to say the collaboration plan that we may connect with each other. Yes.
Okay.
Okay, that's for today. I think it's what time is it now at your side?
We've been on the air for an hour.
Okay, okay. So that's it. It's nice to talk with you, and I have to say bye bye. Okay, have a good night.拜拜。怎么？你说什么？我刚刚说了，等一下，我先说完我的，你先说啊。就我跟他们这个讲完了之后，我们 Craig 和 Kyle，我们也可以，你后续我们可以跟他合作一下，就是看有没有合作。